Thank you very much for the opportunity to be able to present in finals. We weren't expecting to get this far, but we're very grateful and we hope to do a good job right now. So just want to go around quickly introduce everyone on our team since we have time. My name is Keanu Lee. I'm part of IA at Michigan Medicine.
My name is Hugh Briggs. I'm with Information Insurance on the campus side and also with Kane Security at COE.
My name is Carlos. I work with ITS. I'm on the infrastructure team. I'm a Linux Unix system administrator.
I'm Jake. I'm a student in LSA.
I'm Brett Miller. I'm in Information Insurance, Michigan Medicine.
Dale Fay, Michigan Medicine, Information Assurance.
Hi, this is Keshav and I work for HIT's Academic IT.
I'm the same. My name's Sam, Academic IT.
I'm sorry. Mehad Chanik, Information Assurance, Michigan Medicine.
Okay, thank you. That's our team. And if possible, for anyone who has a computer right now, I'd be very happy if anyone could register, try out our product right now. You can sign up for an account. Please don't use your username. It's not HTTPS yet. But please try to see if you can solve any of the challenges that we have right now. And so how we came up with this idea. So this is we see this problem a lot when we're trying to find new people to join our team. So when you see a resume, it's always nice on paper, but then you come to the interview, or even worse, when the person gets hired, it's not really the skills you're looking for, or it's not really what you expected. So there's a talent mismatch. Number two is that sometimes you feel like there's not enough people to hire for your position, or the people you're looking for aren't really there. And lastly, it seems like the training methods we have don't often result in more skilled employees that give more results. So we've seen this a lot in our work, and especially when we're trying to get new employees on our team. So those are the three problems: recruiting, finding the talent, and training, bringing our employees to the next level. So our solution: capture the flag competitions. So what are capture the flag competitions? It actually comes, so basically, in a nutshell, capture the flag competitions are competitions that require a professional skill to solve a specific challenge. So what happens is this platform you log into, there's a bunch of challenges, and to solve a challenge, you need to use a specific skill. So this is used a lot. This kind of technique has been used a lot in the cybersecurity, in computer security industry, where we have, this is some examples where we have Purdue, Palantir, Google, Texas, Carnegie Mellon, UIUC. They're using these skills to build their talent pipeline into future computer security professionals. But we try to abstract this a little more out. And what happens if we build this, but more to a lot of different skills and not only computer security? And so that's what CTFs are. It's also a good way to track milestones as your employees, and we thought we could use these skills to kind of measure and to set milestones for the people we manage or the people we lead to grow from specific skill to skill. That's the whole point. Create tailored challenges to skills you care about. We chose two resources to kind of create our challenges, and we chose the University of Michigan careers webpage, where we just looked at lines on different careers. We even looked at a locksmith position and crafted a little micro challenge for locksmiths. And so we went from the careers page, and we're thankful for everyone who was willing to talk to me. Some people refused, actually, because they didn't want to get too competitive. But we went from these two resources, talking to a lot of people here, and the careers page to determine what are the needs of Michigan Medicine in terms of hiring or talent pipeline. So please try to log into this, and if we have time, we're going to try to talk through the challenges that some of the people on our team have created, if we can talk about it real quickly.
Hi, Keshav and I happen to work on a particular challenge. So we are on a team together that writes web applications. So we thought, how do you assess someone's knowledge of front-end web application? It's common to have to write code in language called JavaScript. Maybe you've heard of it. We created this JavaScript Madness challenge. And so when you click this link, you go to our app. So we created this app, and our infrastructure folks got it going in the cloud, which I don't know how that works, but thank you for those who do. So otherwise couldn't do this. And so here's some app, and it gives you a link, and the link happens to show you some source code. So if you're a JavaScript developer, maybe you see this, go, oh, that's JavaScript developer. It's using the Express library. I've heard of that. And then you see that there's a slash here, which maybe is the web page. There's slash source, which I happen to be looking at now, which spoon feeds me index.js, which is what we're seeing on the screen. And then, oh, what's this? There's slash flag. So I won't have time to solve this challenge for you now, but if you're a JavaScript developer, with some effort, you could kind of study the code here and know that if you go to slash flag, this code is going to run, and that you can provide what's called a request parameter. So you've probably seen question mark, text equals blah, blah, blah. So if you type the right blah, blah to the right, then that'll end up in here. And if you send exactly the right thing, it will get past this and set this to true. And if this is true, then you'll be rewarded by seeing the flag. And if you don't, then you're rewarded with the message, sorry, you did not get the flag. So this ended up being an application, a JavaScript application. We developed it in a Node.js. Node.js is just a way of running JavaScript outside of a browser. Keshav was going to say a bit about the application.
We used a node here to run the application. It's a JavaScript library that would make the application run locally. And but this application is not going to have to run cloud. So we need a Docker containerization to get this thing up to the cloud, and the infrastructure team can build it out there. Docker is something that we never knew, and we learned in the last 24 hours how to Google. Like, we Googled it and learned how to Dockerize the application. Here are some of the instructions that we learned, how to build it and let the Docker run locally. Like, we download the Docker and like application built, and then it's going to be like running on the Docker, and we have to configure some of the node that you want, like the port number that you want to run the Docker on, all that stuff. And we have some of the instructions how to stop it, or after we are Dockerizing it, then we gave the application to the infrastructure team, and they were able to push it onto the cloud. And the URL that you're seeing right now, Sam just showed you, which is port number and the other stuff, that's all the cloud stuff.
So a little bit was already mentioned about the infrastructure in the cloud. So one of the challenges we faced was like, okay, how will we actually host this, and what are some of the tools that we can actually use? Well, thankfully, we could use some of the UMich services that we already have. What you see right now was the AWS environment that was provided from us with the great virtualization team. Me, Carlos, and Jake, we're really now trying to focus like, okay, now we have this cloud environment. What do we have to do to actually get this thing up and running? And if you can see, we only had two main real services. But just from this base alone, we have now the flexibility to enhance this and scale this out greatly. So for example, talk was for the Node.js application, we were able to go ahead and containerize it. Containerization is a great technology. What else do we have here at ITS? We got OpenShift, right? And that service helps provide that kind of expandability that we can kind of focus more on the application, not really worry about the scaling up, because we can already do that. And thank you for the talk. Again? Okay.
I have two questions. I'll ask the first one. How difficult is it to create new challenges? If I want to create a new challenge, what do I have to do?
So in our case, I happen to be a programmer, wanted to assess programming challenges. As it so happens, since I'm a programmer, I had to write a program to assess another programmer. And so it was kind of in my wheelhouse. But there are other examples of other types of challenges. So I think Keanu mentioned a typing challenge. And so he knows how to write code too. And so in order to write a challenge, learning how to code or knowing how to code is probably helpful, or having someone on your team who can write code. In some cases, a challenge amounts to a file. If someone needed to be good at reverse engineering malware, you could upload a malware, like a pretend malware, to a server, and the challenge could be download this malware and figure out what it's trying to do by reverse engineering it. So in that case, you just need to upload a file that someone else can download and study. So programming helps, but isn't required for everything.
Another thing I'd like to add is when developing the challenges, you want to be able to let the user kind of explore and be creative in how they go about the challenge, but you still have to set some kind of like guardrails to make sure it doesn't go too far to the left or right. You know, you still kind of want to maintain that neutral area where we're able to see them problem solve the challenge, use their creativity, but also at the same time, don't make it so we don't want them feeling frustrated or not being able to actually, get the challenge itself.
But it's very easy to push a new challenge onto the server. Yeah.
Actually, to feed off of that question, have you thought about, or do you see a way for it to involve things that are not technical? You mentioned that you talked to a locksmith. I mean, the first thing that popped into my mind is, could they do a bump lock technique just to get a cheap padlock open or something similar? So how would you facilitate non-technical things into something like this to make it more appealing to a broader audience?
Well, what could happen is it's very easy. We could link to modules outside of our site, and then we would collaborate with other members to create those challenges, and then we put the flags in those modules. And it doesn't have to be like a coding challenge, right? So as long as they're able to get through the module, get to the end, after answering conceptual questions or stuff like that, then we'd have the flag at the end, and they'd be able to submit that, and they get the points.
For the locksmith challenge, so what's been done in other CTFs is that there's a physical component to it. There's maybe the lock that's well known, and the flag is inside the treasure case. They get the flag from the treasure case using lockpicking techniques. The platform, capture the flag in that way.
All right, thanks for inviting us back up here. We are mapping inclusivity in the category of DEI. I am Crystal Borgman. I'm with ITS on the campus side.
Hello, this is Houston Kaplan. I'm on the Michigan Medicine side.
I'm Caitlin Dickinson, and I'm with LSA Technology Services.
And I'm Abby Roloffs, and I'm also with LSA Technology Services.
So the main problem that we're trying to solve is that it's difficult to find accessible restrooms, gender-inclusive restrooms, other similar resources such as lactation rooms, reflection rooms, changing tables. There's a campus map website out there. It has parking locations and building names, and that's pretty much the extent of it. Our solution was to use ArcGIS tools to create a web application that's mobile friendly, that would facilitate navigation to these resources. And then over time it kind of grew to add additional features such as use of augmented reality for wayfinding and crowdsourcing updates to the map data. So this is the campus map that I mentioned. Not a whole lot on there. It's useful to a certain degree. Next one. If you wanted to find accessible restrooms, you could go to the Services for Students with Disabilities website. There is a list. Same for gender inclusive restrooms. If you go to the Spectrum Center website, there is a list. Lactation rooms are on UHR's website in a list form, and the Trotter Center has reflection rooms. But if you don't know your way around campus too well, it can be very difficult to locate these. And we also found that some of these lists happen to be missing some known locations, and so we viewed it as rather incomplete. And so we really wanted to marry all of this information together into one location and using a tool that was easy to use.
So as Crystal mentioned, our main goal here was to consolidate all of these different resources into one easy-to-use web map to make campus more friendly and more accessible to a wider range of people. In addition to that, we also wanted to combine some existing out-of-the-box tools in innovative and useful ways. So we used a number of ArcGIS tools from Esri to do that. And finally, we wanted to, for a change, try a Hacks with Friends project that involved minimal coding, because we thought that this event should be fun for people who can't write code too. We mostly succeeded. We caved yesterday and used a little bit of JavaScript, but for the most part, it was good. So the way we started this project, we did make a map, but we'll get to that in a second. The first thing we did on our project here was consolidate all of the information from those different websites we looked at. So as a team, we created this consolidated list of restrooms on campus and cross-referenced them with those different data tables we were looking at. We next used ArcGIS's web app builder to build a web application where you could search by gender and by accessibility, and then apply your filters to update the map. We didn't really like how this looked, and it didn't have all the options we wanted. So this is where we caved and used JavaScript to create our own custom web map, which was the one that you saw this morning. And we'll demonstrate that a little more in detail now. So we gave you the link earlier. Some of you may have opened this on your mobile phones. It's out live on the web right now. You can check it out. It is mobile friendly. So this is Central Campus, which is where we decided to narrow our scope of our data because there's just too much out there for the 4 of us to do in a day and a half. This can be filtered by restroom type. So if I look at just gender inclusive restrooms, this is gender inclusive accessible restrooms. And if we look at Ross specifically, this is filtered to the first floor right now, so we can see that there aren't any gender-inclusive accessible restrooms on the first floor of Ross. If I change this to all floors, now I can see that there is this one restroom here on the 4th floor. I can click on it for more information, and it will even show me a photo of the entrance. I can limit what's shown on the map, so I could turn off the restrooms and say only show me reflection rooms, and similarly I can click on these for more information. And if I choose to show a lactation room, some of these have restrictions on access, so this includes a more info link where I can get to the HR site that shows me how I would get access to those individual rooms. One of the things we noticed as we were doing this, as we mentioned, is that there's a lot of data missing. So our next step was to develop a collector application where we could crowdsource updating or fixing information on the app.
So Collector for ArcGIS is a out-of-the-box app that they provide. Everyone at University of Michigan has access to download this app. We pay a site license across the university. So we're able to leverage the same resources that Abby used, that we used for the interactive application you just saw in this collector map. So I can open the map. And you can see here we're at the Ross School of Business. And one limitation of this inside is that our phone GPS doesn't work very well. So you'll see a very wide circle around the point. But to add something, we can simply click the plus button and say, for demonstration purposes, we'll say there's a restroom here, maybe. And I'll select it's a women's restroom. I can say what floor it's on. I can select first floor, maybe it is accessible, and the building name is pretty easy. I can just filter for Ross. It has found my location, but maybe it's out in the street right now, and I want to change it. I can just update the point and use my target location right now. I can then submit my record, and it's added it to the database. But maybe this was added incorrectly and someone was just going around sabotaging our map.
Or adding points, restroom points in the middle of an auditorium.
Exactly. So this actually goes through our approval process. So we have a a separate view of this data that is used in our web app. And should we show that now?
It's going to be hard.
Okay. Anyway.
This point wouldn't show up on the web map yet. It hasn't been checked and approved, so it wouldn't show up on the web map until someone has approved it.
So that's how easy it is to crowdsource information with this technology. The other one other challenge we faced was, no, not a challenge, is how to provide directions to access some of these locations. And so this is an application called AUGeo, which is also part of the Esri ArcGIS suite of applications. And so with this, I can find a reflection room. We did this with reflection rooms because there were fewer of them, so it was better for demonstration purposes. But I can click on the nearest reflection room and see on the map how I would get there. And it tells me the distance away and also the bearing, if you're really into that. So one of the challenges that we faced with using the restroom data is that all of the data points would be stacked up one on top of each other for different floors in a building, for instance. So one of the things that we hope to do next is to add elevation to our restroom layer so that restrooms on the 3rd and 4th floor would appear higher than those on the 1st and 2nd floors, and it would be easier to navigate.
Additionally, we would like to incorporate additional accessibility information to be used for routing, such as ramps, curb break, construction information, accessible door locations. Quite a few other universities have official campus maps that include this kind of campus information, and we think it would be great if U of M was one of those as well. Incorporate this into an official campus map so that it is, something that people see when they come to the University of Michigan. It's possible to do custom code development to put UM branding on the AUGO app, so people could use that augmented reality app and have it look like an actual U of M native app. And we could potentially build a native app also so that users don't need to download ArcGIS Collector to submit new information. They could download the U of M version of this app and submit information that way. Finally, here's the link to the map we made. You can go check it out now. If you're interested in using Collector to contribute data to this map, talk to us. We can show you how. It's pretty easy, as you saw. That's it. Any questions?
Questions for our hack team?
Yes, I have a question. Are there APIs or ability to integrate that into the existing University of Michigan app?
So
research that.
We didn't research that.
Okay.
I know the existing University of Michigan app has a place at the bottom of each page where you can link to other apps, so it could be included there if it couldn't natively be included into the app itself.
Okay.
Do you know if there's any live data sources you can get to? Because you started with really a static map, and then you're now going to just rely on people to tell you how it really is. Do you know if there's some source somewhere you can actively just get that already approved data?
We know that the facilities databases obviously include all of the restroom information. We requested that and they weren't willing to share it. We don't think that there's any existing source, especially for changing tables, which are, we learned through this project, few and far between on campus. And we're relying solely on the websites of HR and Charter for the reflection and lactation rooms.
Do you see any challenges associated with, and maybe this was part of the facilities decision, I don't know, but safety and privacy in any kinds of ways? Is there anything that you think is particularly challenging or not to either the process or the outcome?
So we did think about in outsourcing the data, there would need to be some controls on who could update things and what could be done. As far as safety, most of the buildings on campus have a map when you come into the building where you can see the restrooms. So we don't see this as surfacing any information that you wouldn't be able to find otherwise. It's just making it easier for people who need it. I suppose encouraging people to take pictures of restroom doors could potentially be a privacy concern. We would maybe think twice about that, but we wanted to demonstrate the capability to do that. I did feel a little weird taking a picture of a bathroom door this morning thinking, I hope no one walks out of here right now.
Hello, we're team number 10.
Wait, oh, sorry, I couldn't find a parking spot. I apologize for being late.
Okay, proved our point. We're team number 10, My Park, and we are presenting today a parking reservation system for the hospital medical campus. As anyone who's visited the medical campus probably knows, parking isn't ideal. Here's some of the testimonial feedback that we've got from certain people on campus. And so the problem that we had was to try to alleviate the pain that causes. And so we've come up with this solution.
So how do you address such a complex problem? Well, one way you can do it is our proposal, which is a software-based solution with a hardware component. And it involves setting aside a block of parking spaces in every deck and lot that you would make reservable. And through a web application, you would reserve those parking spaces ahead of your appointment, receive a confirmation, and then when you park, you're going to have a low-cost hardware solution to monitor that parking space so that when the right person comes into that space, they are prompted to send a confirmation code, which they received at the reservation, and then go ahead and be given permission to stay in the space. This gives us a lot of opportunity to do some advanced analytics because it's a tightly controlled platform.
So I think Mike's covered most of this, so I'm actually on. For the minimum viable product for today, we wanted to deliver a functional web application that reserved a parking spot in specific structures, one that gave a confirmation text, one that sensed entry and exit and sent another text on arrival and departure to the user. For today, we're assuming a 2-hour limit, and we provided a report of the current state using Tableau. And so now we'd like to actually show you a demo.
All right. So just a quick demonstration of the hardware solution that monitors the parking space. I'll slide over here and go here. Let me just put the mic down for a moment.
As you can see, this is the hardware for the parking spot. You come up and you would have reserved it. It's kind of hard to see.
So blue is a vacant space, and then as the vehicle comes in, the ultrasonic sensor detects it, changes to red. Red is a occupied but unconfirmed space. Then the visitor sends the text message, and it turns, leave it there, and then it actually, once it receives the confirmation message from the visitor, then it'll turn into green. So that shows that it is occupied and validated, and then whoop, away it goes. No, I wasn't supposed to do that. Got a little sensitive right there. So you're supposed to bark out, and when you back out of the space, it's supposed to shift right to blue right away. So anyway, that's the hardware solution that monitors the parking spaces.
So I'm going to give you an overview of our web application and how So if you come into the Michigan Medicine website and you select parking reservations, you'll have a 3-step process to reserve. So you pick a date. We could say next Monday, and then we select a time within a half-an-hour block, noon. Step is to pick out of the 4 available structures that are still available that have vacancies for reservations are these. So we could pick the parking structure. Next step is going to be for me to enter my cell phone number. Please don't spam me. And then a fake license plate number, because I'm not going to give you my real one. And I click book. Now, you can see as I have SMS set up on my Mac, that I have just received a notification for that. So my reservation parking spot is RS61, and then my confirmation number is this. So when I end up pulling into the parking spot, as they just demonstrated, I would return with that code. And then this is what's going to trigger the light from going from red to green, so that a parking attendant that is driving through the parking lot will know that this is a valid car that has a valid reservation. And so if someone, for instance, just found that open spot, they didn't have a reservation, they didn't have their they didn't get this code because they didn't enter their cell phone with this reservation. So they're able to tell right away that they were parked there illegally. So when we leave, I can just, again, back my car out, and it will automatically then make the space available, or I could even text this return code that came in, and it will back me out of my spot, and it'll make my spot available a little bit quicker. Thank you.
Right, so the solution architecture we came up with, as you saw, was a web application. The web application talks to a web service on the back end, which talks to our parking database, where we have information about the parking structures and floor spaces available, existing reservations. And so the web service queries the database, finds out for a time slot that you selected what is an available spot, and assigns that to you. We use a cloud-based SMS and voice service called Twilio to do the sending and receiving of text messages. And the web service also has integration endpoints for the parking hardware.
A few details on the backend database. We have an Oracle database with 4 main tables. The first 3 are pre-populated, so we have parking structure info. We just picked 5 lots on the Med campus, P1 through 5. The second is parking floor, and so how many reservable spots are there on each floor? Are they handicap accessible? Is that floor covered? And then parking slots, so detail on the individual parking slot information. And then the last table is what's populated by the API, and it gives all the reservation details.
So one of the features that we included in the product was a dashboard for the people, for the business managers who are managing the space, as well as the parking attendants who are investigating spaces that may be used by people who didn't reserve. So this gives them an overview of what the current state of the reserved parking is. So blue indicates that there's a vehicle or the space is occupied. The light gray indicates that the space is empty with no pending reservations, and then the orange indicates that there is the space is currently empty, but there is a pending reservation in the next few hours.
The picture is to get a smart parking system with all the hardware and space utilization tracking implemented. Some of the questions that we talked about or discussed was, how do we know 2 hours is enough? Or is there a way that we can integrate MyChart to suggest what's the best parking structure or estimate the duration based on their previous appointment?
questions? Any questions?
Questions for Team 10?
Saying right at the end that the system would be able to, so the business owner, whomever is managing kind of the parking spaces, would be able to see, particularly those spaces that have a pending reservation. And you mentioned that that pending reservation might occur in the next few hours. When I think about the healthcare space, right? You were saying just now 2-hour reservation, is that enough or not? What do you think about the fact that those spaces may need to move more quickly than that? Holding a space open for 3 hours, perhaps may not go over well, and only in the sense that that's a space that's needed for the very reason you're creating this. So do you see is there some way that, is it the business manager that would be able to maybe manage and reallocate that spot or put it up? Can they control the amount of time it's available? Is there some way to manage those so all spaces are used all the time?
Yeah, I'll start with the answer and other folks can chime in. We talked a lot about enhancements, and that was some of the scenarios we talked through. So we worked through a series of use cases like that, decided they were out of scope this time around, but in terms of optimizing actually space usage, there's a couple of things we played around with that could mean in the future we would add something like a total cap on time that are allotted for a space. Someone who did not confirm within their appointed time by 5 minutes or 10 minutes can immediately surrender their space. For the hardware solution, the nice thing about that is that it doesn't necessarily require the honesty of the person habitating the space to notify the system when they back out. So if they leave the appointment early, the hardware actually should pick that up and free the space up immediately. So, and as we were saying, there's some opportunity for analytics as well. Over time, we may find that the system can be optimized for more of this kind of activity.
And another point, we can't solve all parking problems. Well, the goal in this project was really to try to get people in and out in a quick manner, and so they're not late to their doctor's appointments, to try to make sure that, if this is a project that works and we can scope it out bigger, but right now we're trying to focus on 10, 20 cars being able to get into their doctor's appointments and get out, or meeting patients or meeting, whomever. Yeah, the goal is really to get people in and out as quickly as possible, not necessarily tie up spots for long.
Okay, my name's Mandy Chapman, and the hack that our team worked on was hands-free ticket creation. So the problem that we're trying to solve is how to quickly create reports of problems with IT. It could be expanded to further things using a mobile device and then just talking into it, having it go to the correct assignment group based on the things that you said you were having issues with. Because we know a lot of times, is it infrastructure, is it printing, is it whoever, those type of questions are always issues that we have. So it's a virtual assistant, and I'm going to have the team introduce the rest of themselves.
I'm Kranti Bondaru. I'm from ITS Information Quest, and I'm the pitch lead for this hack.
I'm Chris Rowland, and I'm from IQ. I'm a software developer.
My name's Kevin Bouchard. I'm on the HCM team, and I'm an application developer.
My name is Christine Town. I'm with ITS, desktop support.
I'm Matthew Jones. I'm lower on the list. I'm with Teaching and Learning. I'm a developer.
I'm Rob Pfeiffer. I'm with the ITS My Workspace engineering team.
Mark McManamy. I'm with the HCM team, and I'm an application developer.
I'm Luke Pelno, and I'm with the Office of University Development.
Okay, and yeah, we'll just move on. So earlier we did a demo, and we decided that we were going to do an even larger demo that Chris is going to work on. So we are going to switch over to this cool tool so you can see for help.
Kind of looks like an iPhone commercial, but it's Android for life. Talk to For Help. I turned my volume off because I was practicing. Talk to For Help.
Getting the test version of For Help. Hello, how can For Help assist you?
I'm having a problem with the printer.
Okay, I'm sorry to hear your printer is busted. Where are you located?
Ross School of Business.
Okay, you're located at Ross. Please further describe your problem.
It says PC load letter.
Okay, you said it says PC load letter. Should I create a ticket for you?
Yes, please.
Ticket ID 172 created and assigned to mPrint platform as a service.
Yeah, so from here, our conversation is over, and it's produced for you the ticket ID that you can use if you like to memorize that sort of thing. And it tells you that the assignment group that it decided that was relevant based on what it picked up in your speech. You can click on this link and it will bring you to the details of the ticket that you've created. You can see it's captured based on who's logged in at the time. That was me. It shows where it has, the assignment group it has applied it to, the desktop mobile computing and print platform. It also captures in the description that the ticket was submitted via the assistant, that user reported they were in Ross, and the description that they gave. We experimented with adding a few other features. I can come back in, talk to For Help.
Help. Thank you for contacting For Help. What seems to be the problem?
What's the status of my last ticket?
Ticket 172 has a current status of new.
So it seems that they're dragging their feet and they haven't gotten to that yet. Talk to For Help.
Thank you for contacting For Help. What seems to be the problem?
I forgot my password.
Please spell your unique name.
ROWC.
I want to make sure I heard you correctly. Your unique name is spelled ROWC?
Yes.
Should I send the reset code to your recovery email or recovery phone?
Email, please.
Okay, recovery code sent to your recovery email. Is there anything else I can help you with?
No, thank you.
Again?
No. No. That's like the weirdest place it could have not worked. Anyway, so we had several people working on this at the same time and developing kind of independent intent support. So that was one we were working on before we had actually implemented the part where it was asking you where you had to be logged into the device. So where it asked you for the username, in that case, we would just eliminate that part and use the user that's logged in.
As Chris said, it was a real collaborative effort with the whole team, and we did start ground up on this thing when we got here. So one of the first things that we did was sort of just started talking through what the conversation flow was going to be. So we started mapping that out. So in our documentation piece, we have different maps for different conversations, and then where that flow would go depending on what you said. Unless you say no, then apparently it just dead ends. But for everything else, it maps back up. We can loop back. If you say no at one of the questions, we can loop back and come back through the questions for you. Or if it doesn't understand you, we can have you clarify your answer. We kept this pretty high level from a mapping standpoint. Here is basically talking to a device. Of course, right here we've been talking about working with Google, but of course this is work with any other voice technologies that are out there. We were using the dialogue flow enterprise system to be able to handle all of the conversations, and then that's where we were able to put in things like locations of buildings and information like that. And then you come into the decision tree. If you want to create a ticket, then we're sending it off. In this case, the API was going over to Team Dynamics to create a ticket there. But this could be anything. So one of the questions that came up earlier is, this is just, in this case, Team Dynamics. But if there was a situation where the question was, there's a problem with a sink or a facilities thing, that could go to the facilities group. It could really interface with any type of system, any ticketing system that has the APIs set up for it. I think Chris is going to talk about, so this is some of the technology that we're using. Obviously, Dialogflow, Tortu is what we're using for the flow charting, Team Dynamics. A little more about the Dialogflow.
So just to kind of give a real quick overview, every purpose that we want the assistant to serve, whether it's my printer's broken or I can't log in or the toilet's clogged or whatever, would kind of be represented by, for the most part, a single row in Dialogflow where you define the natural language that is going to trigger that intent. So you can give it a bunch of training phrases and you get out of the box the intelligence that Google has from understanding the English language to figure out what you're really talking about. And then as part of your kind of optimization of creating a well-designed application, we can repurpose a lot of these. So problem description is an intent in there. So when it's in the correct context of the conversation, it understands that it's trying to get a location or a description from you. Likewise, there's a location prompt in there. So it understands that at that point in the conversation, you're trying to figure out where the person is. And we've imported data from a facilities database that knows the name of the buildings as well as synonyms for those buildings. In the earlier demonstration, a lot of students, I guess, refer to Duderstadt as the dude, so you can say that because it's a synonym and it substitutes in the known value that we have for that. I think that's all I got for that. Do we have another slide?
No, that was the end.
Okay. I really should have milked it so it ended right on time. We got like 10 seconds left.
Couple, do you have to link your Google Cloud to your UMich, like your Gmail, or how do you, from a privacy standpoint, do I have to associate my account with?
It will, right now the way it's set up, it will submit the ticket as whomever you're logged into your device as.
Okay.
I have, multiple accounts logged into my phone at the same time.
Okay.
So when I'm doing it, I just made sure that the assistant was, the account it was using at the time was my UMich account.
Okay.
And I imagine I don't know actually what would happen if you tried to use a non-UMich account when you created a ticket in Team Dynamics. It might say
They could submit it as a guest account because there's a lot of time that we have guest accounts that get submitted.
But one nice thing about, in particular, the password reset question, your phone remembers who you are even if you forgot your password. So most of the time you're going to be able to pick up your phone and you're just already logged into your phone and it knows who you are and it's validating that for you. And then you can trigger, the password reset.
How does it know the where you are? So beyond Ross, like a printer problem, how does it know that it's room 326, my desk, my printer?
So we took a simplified approach to this for the minimum viable product. There is location data that you can get from the conversation. We chose not to use that because it might be too broad, as you saw in the bathroom one. It's a broad area, and if you're indoors, it might not work very well. So we're just relying on the user reporting. But we can, based on that information, we can look up data that has hardware or whatever that's relevant to where the person is, so we can help, drill down to the particular thing they might be complaining about better.
To add to that point, we have the space data in the data warehouse, so we can pull that information and try to see, if they say Ross Business School, then we'll say these are the list of rooms that are available, which room are you in? And then it provided the data is available in the data warehouse, which is the central repository for the entire university. So there has to be some effort made to kind of put all the room information, then it will work seamlessly, or like it will have more information to pinpoint exact location of that. And also like the hardware as well, like you need to have the hardware information updated, what is available in that room, so that we know that when we are using this application, then we'll know, okay, this room contains this list of all devices, which device is broken or something.
And for a lot of the questions, a lot of the diagram flows we talked about and didn't get into here, a lot of that information may not be needed. So we could this could expand somewhere into like employee self-service. So if somebody can't get into their timesheet, they could just very easily, get the ticket created and tell us, the hardest question is always what's going on the screen. Is it, is it turned on? Is it, what are you having trouble with? So that conversation piece is very easy for them. And then again, automatically gets routed to the proper team so that we can get the tickets faster and process them.
Hold on one second. So to clarify what you just said, you have the ability to present back through the app specific options to somebody. They could just click a radio button or whatever to get input back from them.
Yeah, yes, you do. But the goal of the technology is to keep it conversational. So you want to think in the use case of how would I ask you where you're sitting. So we kept very simple statements where we were just looking for one, like, let's find that building. But really, it was something where you could have it recognize the building and the room number, or the building and the floor and the room number in one sentence, or you could sort of tease it out of someone through more questions.